In this video, we'll discuss surface area. Now, surface area is the sum of all the areas that create the outer surface of the solid. Often we have two very common ones that we work with, which is the rectangular prism and the cylinder. And they have formulas that have been created for them. For example, the rectangular prism says we're going to do 2 times the length times the width, plus 2 times the width times the height, plus 2 times the height times the length. That's the area of the 6 sides that make, or the 6 faces that make up the prism. In a cylinder, this is 2 pi r times the quantity r plus h. So if I'm given a problem such as this, where it says determine the surface area of a cylinder with a diameter of 20 inches and a height of 15 inches, and state the exact surface area and to the nearest whole number, I could use the surface area formula for the cylinder to help me determine that area. So the first thing I would want to do is label my cylinder. Here I have the height is 15 inches and the diameter is 20 inches. But if I look at my formula, I want the radius, not the diameter. So if the diameter is 20 inches, I know that the radius is 10 inches. So I'm going to relabel my cylinder to help me out. Now I can substitute in my values. I know that this would be 2 times pi times 10 inches times the quantity 10 inches plus 15 inches. So I want to follow my order of operations. So I'd add inside my parentheses first, and then I would multiply all of my numbers together. So I'd have the 250 square inches, and then I would multiply by the 2, and then write the times pi just to keep it in some format to get me the exact surface area. So this is 500 pi square inches. And if I rounded that to the nearest whole number by multiplying by 3.1415, which we've mentioned before, that will get me about 1,571 square inches. Now, another way we can think about surface area is through the net of the solid. The net is a pattern of a polyhedron if it's laid out on a two-dimensional space. It's like peeling the outside of that solid, like it's the skin of the solid, and laying it flat, and then finding the area of each of those surfaces that are made up of polygons. And one of the key important things to recognize is that the surface area will be the sum of all of those individual polygons areas that are formed by the net because of the additivity principle. So we can find each polygon or each shape's area, add them together, and that will give us the entire surface area. So let's look at this rectangular prism. Now we could use the formula for surface area to determine it, but we could also construct the net. So if I take the net, that means I'd be splitting it apart and laying it on a two-dimensional surface. And now I can see all the different rectangles that make up this rectangular prism. And they're each labeled. There's 2 blue, 2 yellow, and 2 red rectangles that I now can find the area for. So the area of the blue rectangle is 6 by 7, which is 42 square centimeters. The area of the red rectangle would be 5 by 7, which is 35 square centimeters, and the yellow would be 6 by 5, which is 30 square centimeters. What I have to remember is that there's 2 of the blue, 2 of the red, and 2 of the yellow rectangles. So if I take and multiply each of those areas by 2, and then I add the 3 sums together, I'd get 214 square centimeters. And this should look somewhat familiar to the original formula. It was taking 2 times the length times the width, plus 2 times the width times the height, plus 2 times the length times the height. This is in essence what the net is doing. Now let's think about that from the perspective of a pyramid, in this case a square pyramid. And let's compare how do we go from the surface area formula to understanding using the net. Say that this square pyramid has a base length of 3 inches, a height of 2 inches, so that's the perpendicular height from the base to the apex, and then a slant height of 2.5 inches. Slant height is the height if I look at each of those individual triangles that make up the square pyramid. The formula for a right square pyramid is 1/2 times the slant height, that's the L, times the perimeter of the base, plus the area of the base. And the base in this case would be the square. So that'd be 1/2, the slant height, 2.5. The perimeter, we'd want to label all 4 sides of that square base. So that's 3 plus 3 plus 3 plus 3, that's the perimeter. And then the area would be 3 times 3 because it's the length times the width to find the area of a rectangle. So if I simplify that, that becomes 4 times 3 inches because there's 4 of those. And then 3 times 3 gives me 9 square inches. So I'm looking at 15 square inches plus 9 square inches, which will give me 24 total square inches for the surface area of my pyramid. Now let's look at it from the idea of the net. And I've got how we put together the formula so that we can compare the two. First thing, I'd want to take and lay out all 4 of those triangles. I'd want to peel them back and lay them down on a two-dimensional surface. Now look at what we have. We have 4 triangles in the square base. Each triangle would be 1/2 the base times the height. Well, the base in this case is 3 inches and the height is 2.5 inches. So and then the area of the square is length times width, so 3 inches times 3 inches. So if I put that all together, I would have the area of the triangle times the 4 triangles plus the area of the square. Well, we found the area of the triangle to be 1/2, 2.5 inches times 3 inches, and there's 4 of them, and then times 3 times 3. And if I do a little bit of rearranging using my associative and commutative properties, look at what that becomes. 1/2 times 2.5 inches times 4 times the 3 inches plus the area. It's the exact same thing. It's just a matter of how can we go about understanding how that surface area is constructed. Sometimes creating that net could be the best way for us to understand how to determine the entire surface area.